Alright, let's start this off by finally nailing down what it means for two things to be congruent. So let's take these two figures here, one blue, one red, and you can see that they're not lined up exactly the same. This one's got points and vertices at different places than this one, and we want to know what will it mean for these things to be congruent. So here we go. Here's our final answer to what congruency is. Figures are congruent if they have the same size and same shape. Has to be both of those, not just one or the other. So same size and same shape. The symbol for congruence, we've seen this, but we've never really introduced it fully, is this equal sign with a tilde above it. The equal sign, and this can actually help you remember the definition of congruent, the equal sign tells you that they're the same size. So we think of equals in terms of numbers, so that equal sign below there tells you that these are the same size, all the same measurements, and the tilde actually tells you that they're the same shape. So the figure on top indicates same shape, figure on bottom indicates same size. And so let's now look at this, and what we're going to do is we're going to look at two implications of this definition of congruent. That is, that they have to have the same size and same shape. One of the things that means is that if things are congruent, you can use isometries, that is, transformations that don't change size, to match them up perfectly. So we can use some combination of translations, reflections, and rotations to line these things up, and if they are congruent, they should lay perfectly on top of each other. So through the magic of PowerPoint, I'm actually going to move these around. I'll take the red one and I'm going to translate it over so that it lies roughly on top of the blue one. And now I'm going to take and rotate it about its center. So again, that's another isometry. And if I rotate it about its center, it lays perfectly on top of the blue one. So that tells us that these two figures are indeed congruent. So that's one of the side effects of the definition of congruence, or congruency, is that some combination of transformation will let you lay one right on top of the other. Let's look at some different figures. I've got some triangles here for us to look at, and let's look at another part of this. If two figures are congruent, the measure of every single corresponding side and every single corresponding angle is going to be equal. So corresponding just means the parts that line up when you lay them on top of each other. So I've drawn these triangles where they match up nicely. A is like X on the other one, B is like Y on this one, C is like Z, etc. So if they're going to be congruent, what has to happen is that AC has to exactly match XZ. AB has to exactly match XY. Angle A has to exactly match angle X, and so on and so forth. Alright, so once we've established that these things are congruent, and we know that some combination of isometries is going to map this one directly onto this one, and we know that all their corresponding parts are going to be exactly equal in measure, we can finally write out that, hey, these things are congruent. So all the statement says is that triangle ABC is congruent to triangle XYZ. But the thing is, the way I write those letters is actually pretty important, because that shows what parts correspond to other parts. So in this case, I wrote this ABC for this first triangle. That means for the second triangle, when I write that they're congruent, I have to put the vertex of this triangle that matches A first. So X and A, because they go first in this naming system, they have to correspond to each other. Likewise, B corresponds to Y, C corresponds to Z. This also works for segments. AB is going to be equal to, or equal in length to XY. Segment AC is going to be equal in length to segment XZ, and so on and so forth. So how I write this name is actually very, very important. So when we write out that two figures are congruent, make sure that the corresponding parts go in the same place in the name. That's extremely important and very, very easy to miss. Alright, Another thing is that when we have these two congruent figures, we've talked about the fact that they're congruent, and we want to have a drawing that goes with this. We use what are called hash marks to show that they're equal in size. We've been doing this all along, but now we finally have a formal definition for it. So for instance, I might put a single mark on AC and on XZ to show that those are in fact going to be congruent to each other. If I wanted to show now that CB and ZY are congruent to each other, I would have to use a different set of hash marks. So before I just used one, now I'm going to use two. So everything that has those two hash marks on it are going to be congruent, and so on and so forth. Alright, so to wrap everything up, congruent figures have the same size and the same shape. That means that some combination of isometries will allow you to lay one of the figures right on top of the other one, and every corresponding side and angle is going to be congruent in the two congruent figures, and when we write out a statement that shows they're congruent, we have to match up those names accordingly so that all of that lines up.